kids, it's Mrs. Compton, and today we're going to look at some marbles. So we've got Jake versus Emma, and they both have marbles, and they've collected them in different ways, and they have different numbers of different colors of marbles. All right, so let's check it out. Jake and Emma each have a collection of marbles. Fair enough. What fraction of each collection is blue? All right, so we're looking for the fraction of blue marbles. Now, let's check out Jake's collection. So here's Jake's. What do you notice here about Jake's collection? So maybe you're saying you notice that 3 of them are blue. Do you have to have the total number of marbles in Jake's collection? The answer to that is yes, right? So let's count them out. Ready? 1, 2, 3, 4, 5, 6, 7, 8. So he has 8 marbles. Now, 8 tells us about the whole number of marbles that Jake has. So that's going to be our what? Numerator or denominator? It's going to be our denominator. That's our bottom number. It tells the whole amount. Let's just write that in. Whole amount. Now, in this case, our numerator is going to tell us about the blue marbles because that is what the question's asking us. So the top number will just be the blue. All right, so show me on your fingers. What are we going to put at the top? I see it. 3. Boom. So 3 of them are blue out of 8. So we would say, we would read this as 3 out of 8 are blue. We could also say 3/8 are blue. Both are perfectly acceptable. Okay, so I think we've got Jake's marbles done, but we've got to take a peek at Emma's marbles. Okay, hers look like crazy Pac-Man. Have you guys ever seen the ghost on Pac-Man? I don't know, maybe we're too young for that, but I do. Okay, I know what Pac-Man is, and I actually have Pac-Man on the other side of this wall. Fun fact about me. Okay, so let's see here. Emma has 1, 2, 3, 4 bags. Okay, so we know that she has 4 bags. And we know that each bag has a different color in it, right? But then I also know that she has 8 marbles. 2, 4, 6, 8. So how are we going to represent Emma's marbles and the numbers that are blue? It's an interesting thought here. So we could look at it like 2 marbles. So 2 are blue. Out of, how many marbles does Emma have? 2, 4, 6, 8. Okay, so 2 out of 8 are blue. We could look at it that way, but does anyone see it differently? Let's take a moment and see if we can figure out another way to look at this. So maybe we'll just look at them as like the bags itself. So this would be like 1 group, 2 groups, 3 groups, 4 groups. So now let's look at it as 4 groups. So I put 4 as my denominator because we have 4 groups, and that's our total number of groups. How many of the groups have blue marbles? This would be 1 group. This would be another group, and another group. Well, only 1 group has blue marbles. So that's it. So I have another very big question for you. Is 2/8 equivalent to 1/4? Are these equivalent? That means equal. Are they equal in value? 2/8 and 1/4. Let's look. I feel like I need a picture. All right, here we go. Get my other little whiteboard. I always draw it out. So here's 1/4. Now, how can I break this into 8 pieces without changing my shading? I could do a little dashed line all the way across. Now I have 8 pieces. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. So it was 1/4, right? That one little piece was 1/4. But then I broke it into 8 pieces. And now how many of the pieces are shaded? 2. So is 1/4 equivalent to 2/8? The answer to that is, it is. And we proved it with a picture, right? So now we can see, we can represent Emma's marbles this way, 2/8, or we call this simplified, simplest form. It's just one blue group out of 4 groups. All right, kids, time for you to do your own work, so grab your stuff and I'll see you next time. Bye.